My name is Barbara, and I usually work as an electrical project engineer. But I have been sick all my life, really. A lot of infections, so in and out of hospitals, a lot of operations, and a lot of medicine, different medicines, because the doctors have tried many different things. But then I met a doctor who said, okay, I see what you mean, this is not right. So I got this gene sequencing, and it turned out that I had a gene defect that caused me to get all these infections all over my body.
We need to move away from the treatment paradigm that we have today, where one size fits all, so we need to change it towards more personalized medicine. The Danish National Genome Center was established by law in order to build an infrastructure and to adopt and implement whole genome sequences directly into healthcare. This means that patients, no matter where they live in Denmark, will actually have offered whole genome sequences as part of their diagnosis and treatment.
Denmark is divided into 5 regions that each have their own publicly funded healthcare system. And the implementation across all of Denmark at the same time means that we can offer patients the same access to whole genome sequencing, and also has facilitated more formal collaboration between the different regions, so the healthcare professionals like clinical geneticists, but also other healthcare professionals involved in diagnostic testing of patients with suspected genetic diseases.
The infrastructure that's been built in connection to the National Genome Center has had major impact for cancer patients, because now we have a structure where we can offer sequencing in order to look for better treatments for each patient.
For the diagnosis and treatment of the patients, I think whole genome sequencing basically means a better chance of getting it right the first time.
The patient doesn't have to go through a long clinical workload before getting the exact diagnostic.
We can look at all genes, both coding and non-coding at the same time, so it's a huge advantage, both for the treatment of the individual patient, but also for future patients, because we learn a lot and we can use it for research.
When I talk to the families about having a genome sequencing done, I also inform them about the use of their data in research projects. In Denmark, you have to opt out if you do not want your data used in research. The large majority of the families that I talk to are very positive towards having their sequencing data used in research projects. My impression is that very few opt out.
In order to work with genomes, the infrastructure needed to be built, because genomes are huge amount of data that the human brain cannot adapt to. The supercomputer is capable of handling huge amount of data, both genome data and other data, in order to make more precise diagnosis for the individual patient.
The national strategy did and the national initiative, it made a huge difference in the ambition on behalf of the patients within personalized medicine. So we wanted to take better care of our patients. We didn't want to settle for good enough. We needed the correct diagnosis for the correct treatment, not just something that comes close to it.
More precision medicine should be part of the solution of the problems that the healthcare systems are facing today.
With the right medicine, I was normal. It was like a miracle. I turned 40 that year, so I had a very big party at my 40th birthday with my father, who also had this defect. That was the perfect celebration.